Want to talk about some of these activities together? We have a lot of great conversations going on here. So maybe let's talk a little bit about what some of you all found. First of all, people have, well, we'll go through some of these questions and we'll talk about them in detail. So one of the first things we had you do was, we actually have a pretty interesting experiment. You all keep doing it. We'll see what happens. So one of the first things you did was to just one of the interesting conversations we had over here was if you just hang the paper clip off the edge, did folks see the cart? So if you just hang the paper clip off the edge, do you see the cart move?
No.
Okay, so why not?
The force is not great enough to overcome the force
Overcome
of
what?
the friction and mass and
All right,
all
so
of
there's
it.
people talking about friction. So maybe we should start. We should start back a minute. What are the if we're going to sort of use Newton's laws to think about this problem, what's one of the first things we want to do? What would we talk about first?
Discuss the weight of the mass of the object.
There we go.
Oh yeah.
Okay, so so we've actually got a bunch of objects in here, right? We've got all kinds of objects. So let's talk about if we're talking about the cart. Let's choose the cart, and let's talk about the forces on the cart. So what are the forces on the cart in a situation where you hung a paper clip off the side?
Tape.
Okay. There's a force of the table pushing up.
Yes.
Kind of go back. Yeah.
The weight of the car. And the paper.
Okay, so we've had a lot of interesting conversations about the paperclip. The string, when we have strings and cables changing directions, it actually can get confusing. One way I would encourage you to think about a problem like this. I mean, this is your kit, so they're wanting you to struggle with this particular system. So what I would encourage you to think about is the cart. Remember when I said be the cart, think about the cart. The cart actually doesn't know about the masses hanging off the end of the table. All the cart knows is that what is the cart actually in contact with? What is actually attached to the cart and pulling it?
A paper clip that the string is attached
Okay,
to.
the paper clip, it's called a paper clip string thing is attached to the cart. Okay? So that's some force. We can call it wherever we want. What should we call it?
M1.
The force? You want to call it that? We can call the force M1. That might be a little confusing. String force? Okay. Now you just told me that when you hang the paper clip off the thing, okay, before we get to that. Are these all the forces? How do we know?
Talk about us hanging over the edge.
It can't be all the forces. How do we know?
Because there's a force to the. There's a force to the left. And
Oh, there's a backwards force.
There must be a force.
yeah, there has to be a force going to the right.
There's an opposite force for the force of the string because I just steamrolled you.
Yeah, that's what I was
Sorry,
saying.
guys.
And then you just said,
Okay.
I got excited.
Gifted.
So one of the things we didn't talk about yet that's complicates this a little bit more, but I want you to think about this, is that when we talk about Newton's laws, you can actually completely separate the vertical and horizontal direction. Okay, so Newton's laws applies vertically, and you can just think about just the vertical problem, and then you can also think about the horizontal problem completely separately. Everybody, well, let's talk about what I mean by that. So, does everybody agree with me that you're not accelerating in the vertical direction? so what does that tell you?
Those forces aren't balanced.
So the forces along the vertical direction are balanced. Okay, and that it looks like we got that covered. I think that makes sense. What does that tell us? That tells us these two are, let's say, equal and opposite, equal in magnitude in opposite direction, right? Okay, now along the x direction, or along the horizontal direction, we've written if we got a proper situation. Now, we had some comments about force going in this direction. Does everybody agree with that? Well, we have to, right? Because in the horizontal direction, we have to balance forces. But what is it?
Friction.
The tires.
Okay, friction, tires.
It's
Tires and the
either the
cable.
tires, a little bit with the tires and the cable maybe, but it's like really the axle.
Okay, there isn't. I'm not going to tell you that I know precisely what it is, but I think all of those things are probably contributing. The axle, there's a certain amount of force we have to overcome for this kind of the static friction of the system. Does everybody agree with that? Okay. So what should we call that? We'll call that resistance. Yeah, there you go. Resistance. And call that static. This is static friction. You folks have heard that term before, static friction?
That
Sure.
seems
Okay.
not moving.
Okay, static friction. So this is not static friction. The friction that book is feeling, there's a friction that's resisting motion, but we also have static friction, or we also have friction when we're not moving. That's what, when I press against this chair, what's keeping it from sliding across the floor is some frictional force. But we call it static friction because it's the friction force when the object isn't moving relative to the surface that it's touching.
But there's some force on it.
Correct. You really are only going to have friction force. Yeah, it's going to be equal and opposite to the force that's. Is that what you mean?
Well, I mean, there's force acting on that chair when you're pushing on it. Otherwise, there is no force. I mean,
Correct.
So it's not moving because I haven't overcome that resistance yet. So my force is not enough to overcome the static friction.
Correct.
But if I take my hand off of it,
There's not
friction
really
has no relevance because it's not.
Right. Matter of fact, we know that there can't be a friction force in any direction. Otherwise, the friction force would be moving the chair because there's nothing opposing it. So you're absolutely right. That friction force is only there when there's something, that kind of adjusts depending on how much force is opposing it, up to a point that you overcome it. So there's a threshold. And that's what you determine. So what did you do? So then you start putting washers on. So what did people find? How many do you have to put on? I bet, there's going to be numbers all over the place. But what did we find? What's that? Six.
Ours
Do
was
we
six
have a-
at first, but what we realized was that we were kind of dropping, like we weren't, everything was perfectly still. It took 8.
Okay, 8.
We took 15, 12, then 8.
Okay. So I think it makes a lot of sense that they're all over the map because it kind of depends on what we just described. I mean, so you're overcoming the static friction. That should be depending on how the wheel is touching the surface, or if one of these plastic pieces is binding one of the wheels in a funny way. I mean, all those things could be affected.
We also had a difference in which axle though.
Okay.
Fairly significant. When we had it with the small wheels in the front, we got a higher number. Turn it around and hook it to this and have this going over the edge. It moved easier. It moved with less mass on the string.
6, then in the anomaly 11, and then 5 and 4.
Yeah. So, I think, again, it could be that, where precisely the force is being applied. I don't know.
I think it's torque. and rotational force there. I think it has to do with, like gears on a bicycle.
Well,
Bigger gears turn easily.
well, what's different also is that one of the axles is fixed and the other is.
It's like that front-wheel drive and rear-wheel
Well,
drive.
no,
we're
not
talking
quite though,
about.
because we attached this
Oh, I see.
this to it, so it had a chance to move more easily, maybe because the axle was going through this.
Yeah.
So,
I remember when you were talking to me about the rear-wheel drive and how people don't want to have a rear-wheel drive car because it wiggles in the front when you're trying to
Well, but I mean-
start out with do that.
In this case, it
Not
really
this
is.
Volkswagen.
In this case, it's
In the
really
snow.
front-wheel drive in both, no matter which way you're. I mean, it's front-wheel drive in both circumstances. You just have to take the front
Oh, that's
wheel.
right, because the axle's still.
It's on the front side.
Anyway, sorry, we
No,
don't
no, no. I
get
mean, it's,
distracted by
that's
that.
part of
But
what.
when the little wheels have a fixed axle and the big wheels had a moving axle, so does that make a difference?
It might. I mean, it might be that the fact that you're applying the force to the moving axle helped get it past that static friction a little bit more easily. But that's.
Too many variables.
There are a lot of variables. All right. So let's talk about this. So did folks like diagram this out and draw the we drew all the forces on this card. What about the what other if we go down here, what are the forces on this object? What's that? There's gravity. So what do we call again? Let's
Weight.
use the right language. So the gravity is applying the force to this, but what is the force? It's the weight of the weight of the washer. What else is?
Force of the string.
All right. Is that the right direction?
Well, that's.
Okay.
String have two different forms.
We're looking at two
Never mind.
systems.
No, it's not. It's not as simple. It's actually something you want to think a little bit about. It's
Yeah, I know.
okay. The string is funny because this is why you want to be careful about how you approach a problem like this. You want to be careful. You first want to say, what object am I talking about? Because that string is applying force to both this mass and that mass, but it's applying a force in completely different directions, right? So it really depends on what perspective of the object that you're talking about. Okay. So this object, the force of if you think about it from that object's perspective, what direction is the force of the string? Obviously, it's up, right? From the perspective of the car, it's obviously going to the right. Okay. All right. Did folks, so let's talk about well, okay, so once you start, so when this is stationary, when you're not moving,